Find the equation of the line that has the given slope and passes through the given point. Write the equation in the slope-intercept form. M equals negative 5/9, comma, ordered pair 5, comma 4. So what we're being asked to do is to take the given information. We have a slope, we've been given a slope, and we've been given an ordered pair to a point. So when we have the information is being given as a slope and a point, or a point and a slope, we should use point slope form to start as a starting point to develop an equation. Any equation, use point slope form of a linear equation in two variables. Now, students have a little bit of a difficult time sometimes at the beginning remembering what point slope form looks like. But here's an easy way to derive point slope form. From something that might be familiar, which is what's called the algebraic definition. It'll look familiar in a sec. The algebraic definition of slope. And we use the variable m as the variable of choice to simulate refer to slope. So if this looks familiar, look, the algebraic definition of slope, m equals, I've heard it be said as wine glasses over picnic table, y2 minus y1 over x2 minus x1. Okay, well, if we start with this is the definition of slope, but what we're trying to derive is point slope form. If we were to take this guy and put this, make this m over 1, then what we're allowed to do, now that it looks like a proportion, is we're allowed to set cross products equal. Okay, if I put parentheses around the numerator and denominator, then set cross products equal, I'm multiplying this numerator times this denominator. Look, it's 1 times y2 minus y1. And then here, there's the one cross product. Here's the other cross product, m times x2 minus x1. There's the two cross products for this proportion. Set them equal to each other because it follows the rules for proportions. Now go ahead and simplify. I'm going to do 1 times y2 minus y1. Anything times 1 is itself. We're going to leave, though, the right side as m times x2 minus x1. At this point in our derivation, what we're going to do is we're going to take the subscripts of 2. See these subscripts of 2? And we're just going to erase them so that we get this. And maybe we'll write the whole thing in blue. Y minus y1 equals m times x minus x1. So all we did was we erase the subscripts of 2 from here to here. That's what we did. And now we have this is point slope form. Point slope form. Where m is a given slope. And this y1 and this x1, they come from x1, y1, a given point. And this is where we say, when someone gives us a point, like an ordered pair version of a point, and a slope, we can substitute it into these parts, slope, and x1 and y1, into this point slope form. So let's rewrite now we have the slope is negative 5/9. And the point that we're being given is the point 5, 4, which, we know that the first coordinate of an ordered pair on an xy rectangular coordinate system, the first number is an x, and the second number represents a y value. So we're going to make this x1, 5 is x1, and 4 is y1. And we're all set to substitute into y minus y1 equals m times x minus x1. Now I'm going to make room. We're going to use parentheses for substitution. And look, I'm making room for y1 value from our point for m. I'm going to upgrade parentheses to brackets. Here's this x. The reason I did that here is because I want parentheses to put a x1 value in. And now we're all set to make some substitutions with our given information. So here's it, we can go in any order. Here's like m. M is negative 5/9. I put it in here, negative 5/9 into our point slope form. x1 is 5 and y1 is 4. Now we can simplify. So let's maybe go back to blue, and I have y minus 4 equals negative 5/9 x minus 5. We're getting there. What we wanted to do, what we could do here is, remind ourselves now, when I get to this point of I've got the information, the point and the slope information substituted into point slope form, I go back to the instructions and I go, okay, they want the answer in slope-intercept form. They want us to rewrite, any kind of equation we have into slope-intercept form. So our goal at this point, our new goal, is to rewrite this equation, or write it, however you might want to see this, into slope-intercept form. Slope-intercept form, which has the look of, maybe we can do this. Let's write this one in green, because we're keeping track of the different forms of equation. Slope-intercept form looks like this now. Y equals mx plus b. So what this has is y with a coefficient of positive 1, the x term on the right side, the constant term being added to the x term, and the slope and the y-intercept are their own terms connected by addition. And the x term is a number times x, plus or minus, really, a constant. That would be a slope-intercept form. So what are we going to have to do to this equation? Well, one thing I would probably do is, to start converting it closer and closer to slope-intercept form, is I would probably take the fraction and distribute it and see what we get. Okay, so I'm going to go ahead and take this fraction, take this equation, y minus 4 equals, okay, here comes this distribution, negative 5/9 times x. We get negative 5/9 x. Now, negative times negative makes positive 5/9 times 5. So here's the distributive property at work. Now we're going to multiply two fractions straight across. What we get here is, when we multiply straight across, is we get 25 over 9. 25/9. Next, if we clean this up a little bit, we have y minus 4 equals negative 5/9 x plus 25/9. The only thing left to do to get it into slope-intercept form is to add 4. We need to make sure that all constants appear on the right side, added to the x term. So at this point, what we have is negative 4 plus 4 is 0. That leaves us with y equals. We're really close to being done now. At this point, we're going to take 25/9 and add 4. Well, we're adding a whole number to a fraction, so what we can do is turn 4 as a whole number into a fraction by putting it over 1, and then realize that we really need to develop an LCD and make conversions to equivalent fractions. So the LCD between 9 and 1 is 9. The LCD is 9. And we're going to multiply this guy by 9/9. So we're going to get 25/9 plus 36/9. The numerators are addable now to where we go 25 plus 36. 25 plus 36. I'm just making addition in the numerator. 11 carry a 1. This is 3 plus 3 is 6. So in the very next step, what we get is 36. Pardon me. What we get is 61 over 9. When we do this addition, here's the result. And what's to the left of it is negative 5/9 x. And this on the left side this whole time, since we added 4, is just y equals. Now, have we achieved our goal of writing this equation into slope-intercept form? Let's just check the parts. Here's what we were looking at for what slope-intercept form is. Y equals mx plus b. Do we have a number times x? Yes. The slope of this line literally is negative 5/9, and these pluses match. The y-intercept is at 61,9, or 61/9, and the coefficient of y, the reason we can read all that is because the coefficient of y is a 1. So we've achieved our goal, and now it's just the purpose that we have to fulfill is to select the correct answer that matches the answer that we're confident with. Y equals negative 5/9 x. Okay, which one of these answers have negative 5/9 x? This one, A, is viable as far as slope and the slope part of the equation. Positive 5/9 x, that's not right because we have a negative 5/9 for slope. So C can't be the answer. D has the correct slope. Okay, so A, B, and D have the correct slope. Now, plus 61/9. Plus 61/9. Well, when we look at B is minus 61/9, that can't be right. D is minus 61/5. Wow, the sign and the fraction are wrong. But look at what's just right. Here's positive 61 plus 61/9. So we're going to make the appropriate answer choice, and we're going to select A because A is the answer that shows the correct equation. Okay, hope that helps.